Hello, beautiful people. Let's continue our discussion on organic chemistry. So we've been talking about the different functional groups that are given to us in Table R. And so far we have covered a lot of them. Remember that different functional groups basically just represent that those compounds are going to have different physical and chemical properties. Today we are going to be talking about the amines and amides. These are two of the functional groups given to you in Table R. Amines have a nitrogen in the middle that is bonded with three R groups. Now, one of those R groups normally or typically is a carbon chain or an alkyl group, and the other two R's are hydrogens. But one of those other two R's can also be another alkyl group or carbon chain. So an easier way to think about amines or to remember amines is, let's say we look at ammonia. Ammonia has a nitrogen in the middle and it is connected with or bonded with three hydrogens. And then there's also a lone pair with that nitrogen, because remember the nitrogen has 5 valence electrons, so if 3 of them are bonded, the other 2 are going to stay as a lone pair, so that nitrogen has a complete octet. Now, if we take off that hydrogen, or if we remove that hydrogen from this ammonia, and we substitute that with an alkyl group like this, CH3, now we have an amine. And as I mentioned earlier, if we take off the other two hydrogens, or one of the other two hydrogens, and we substitute that with other alkyl groups, then that is still going to be an amine, because we have a nitrogen in the middle bonded with three other things, and those things are either carbon or hydrogen. Now let's look at this example of amine given in Table R. We have 1-propanamine. The prefix, and let's write a structural formula for this compound. The prefix prop represents that we have 3 carbons in the carbon chain. So there we have our carbon chain, and then because it's an amine, it's going to have that NH2, so a nitrogen that is bonded to 2 hydrogens, that part at the end. And then we'll just go ahead and make sure that we put the hydrogens with the rest of the carbons so that they have a complete octet. And now that 1 at the beginning of the name of this amine just represents where on the carbon chain do we have the nitrogen attached. So in this case, if we start counting from right to left, then there we have carbon number 1, carbon number 2, carbon number 3, and our nitrogen is at carbon number 1, which is why we have the name 1-propanamine. The amides, just like amines, also have a nitrogen that is bonded with hydrogen or carbon. The only difference is that the carbon, one of the carbons that this nitrogen is bonded with, has to be double bonded to an oxygen, just like we see in an organic acid functional group. So that blue box represents the functional group amide. So let's say we have an organic acid, so this is an organic acid that we are looking at, and then we have an amine somewhere. So there we have an amine with a nitrogen attached to 2 hydrogens and 1 carbon chain. Now, if we take off the OH part from our organic acid, and we take off the hydrogen from the amine, that OH from organic acid and hydrogen from the amine combines to form water, and the carbon and the nitrogen can then bond together, and there we have the functional group amide. So that molecule that we see right now, if we bring those two things closer together, that is an amide. And this thing that we just did, this reaction is called a polymerization reaction, which is another type of organic reaction. We'll discuss that in a little more detail later. For now, just remember that this is one type of polymerization reaction, because in polymerization we use the smaller organic compounds, which are called the monomers, and we combine them to make larger organic compounds, just like we did in this case, and this larger organic compound is a polymer. So monomers combining to make polymers. Now, if you look at this amide given in Table R, we have a propanamide. Once again, the prefix prop represents that we have 3 carbons in the carbon chain, and because it's an amide, that means the last carbon has to have a double bond with an oxygen, and then it also needs to be bonded to a nitrogen, and in this case our nitrogen is bonded to 2 hydrogens. And then we'll go ahead and fill in the hydrogens for the rest of the carbons, and there we have our propanamide. If we are asked to name an amine or an amide, the first thing that we want to do is definitely identify whether we are looking at an amine or amide. The next thing we do is we drop off the E from at the end of the name of the alkane. So let's say we have a methane, we have an ethane, propane, butane, whatever we have, depending on the number of carbons in our carbon chain. And then we substitute that E with the amine or amide. Let's look at some examples. So here we have a compound and I want to name this. The first thing that I want to do is identify whether it's an amine or an amide. I look at the functional group, I see a nitrogen there which is bonded to 2 hydrogens and a carbon. And the carbon in this case is just a regular carbon in an alkyl group. So that means this is an amine. And then I have to identify the alkane that we have here. So we have 2 carbons in the carbon chain. That means we have an ethane. I will drop off that E at the end and substitute that with an amine. And there we have the name of the compound is ethanamine. And because it's an amine, I also want to tell where exactly or on which carbon do I have the nitrogen. So in this case, our nitrogen is at the first carbon, so that will be the complete name, 1-ethanamine. Here's another example. Once again, when I look at the functional group here, I see an NH2 which is bonded with a carbon, and this time the carbon is also double bonded with an oxygen. So that represents an amide. Then I look at the carbon chain. I see 4 carbons in the carbon chain. That means we have a butane. I drop off the E from the end and substitute that with an amide. And the name of the compound is butanamide. If we have to draw an amine or amide, the first thing that I want to do is start off by drawing the carbon chain. So how do I figure that out? We look at the prefix. The prefix in this compound is F, or ethane. That represents that we have 2 carbons in the carbon chain. And then I know that we are looking at an amide. That means in my functional group, the last carbon should have a double bond with an oxygen, and it should be bonded with an NH2. And then the last thing we do is put in the hydrogens. And there we have the ethanamide. Here's another example. First thing we want to do is draw the carbon chain. The prefix is prop. That means we have 3 carbons in the chain, and we have an amine there. So that means and the amine is at carbon number 2. So at carbon 2, I draw an NH2, and then we substitute the hydrogens elsewhere. And there we have 2-propanamine.